Hello, everyone. Welcome to NEO Battery Materials Investor Webinar Briefing. We are glad that everyone has taken the time to come out to today's presentation, and we hope that there are many takeaways today. Before we get started, we would like to set up brief expectations for the webinar and announce cautionary statements for the information being provided today. First, the webinar is expected to run about 40 minutes. During the webinar, the chat function is live, but please refrain from using the chat, with exceptions of commenting if you cannot see the shared screen or cannot hear the audio. If you have questions that would like to be answered, please email us at info@neobatterymaterials.com. That is, again, info@neobatterymaterials.com. And I'll upload the email address on the chat right now. Last words before we get started on the webinar. We would like to advise all attendees that management will be using forward-looking statements within the meaning of the applicable securities legislation, as well as management's objectives, strategies, beliefs, and intentions. Forward-looking statements can be frequently identified by such words as may, will, plan, expect, anticipate, estimate, intend, and similar words referring to future events and results. These statements and information are based on assumptions management believes to be reasonable at the time such statements are made. As we all know, there can be no assurance that forward-looking information will prove to be accurate, as actual results and future events could differ materially from those anticipated in such forward-looking information, and we caution against placing undue reliance thereon. We assume no obligation to revise or update these forward-looking statements except as required by applicable law. Now I'll pass on the mic to CEO Spencer Huff.
Hi, everyone. I'm Spencer Huff, CEO of NEO Battery Materials. How are you? It's 10 a.m. in South Korea and 8 p.m. in Toronto, 5 p.m. in Vancouver. And yeah, there must be a lot of shareholders from US as well, and even from European countries as well. I've been working here in South Korea for more than 14 months so far. I'm dying to see my family in Canada, but unfortunately, it will take more time to have a nice dinner with my family in Canada this year, because we will have a lot of things to do, because we have a lot of things to achieve this year. I believe this webinar is very important at this time, because the financial market is still so volatile, and all of us have been affected significantly and negatively, driven by this downside market situation. Unfortunately, there are a lot of variables and uncertainties surrounding the current market situation. But personally, I do see some market improvement, potential in 2023. On top of that, I feel confident that NBM will do well. NBM will do very well this year, because our growth momentum will be consistent, through 2023. Currently, we are fully committed to move forward our commercialization process, including our optimization process of our product. Through this webinar, we will share more detailed corporate updates which couldn't be explained from our past news release in writing. Especially, I'd like to share, some kind of, special event. We have a plan that we will invite some of our valuable shareholders to visit our R&D center and our site for commercial plant in Pyeongtaek here in South Korea. I expect that we will have the event in the first half of this year. Okay. Then our corporate analyst will go through our agenda and presentation for this webinar, followed my introduction comment. Let me start first. I'd like to introduce our engineers for the silicon anode plant and the core researchers at our R&D center at NBM Korea. Unfortunately, it's working hour in South Korea. They are focused on what they are supposed to do today. So I will just, the report, they are high to you, all of them at this moment. They are very valuable assets for the company, and especially three seniors have over combined 50 years of working experience in this area. So now, Danny will take over and to deliver our briefing and the presentation. Danny?
Yes. So we'll first watch a short photo slideshow of the before and after construction of the NBM Korea R&D Scale-Up Center. The video will highlight the various manufacturing and optimization activities taken by our engineering team, and we'll give you a brief highlight of our activities in 2022. Before the scale-up center, the NBMSiDE manufacturing process mostly occurred through sending inputs back and forth between necessary facilities. Not only did this cause delay in terms of logistics and shipping, but quality control was also a difficulty as different environments and variables could affect the outcome and performance of the samples. It meant that there would be more room for variability, which may have led to inconsistencies. However, over the past year, NEO has successfully constructed the scale-up center and procured the necessary equipment and machinery for a one-stop shop for NBMSiDE. We were able to tighten the feedback loop, and the optimization of our materials are currently occurring efficiently faster than ever. So we'll now move on to a brief corporate presentation about NEO battery materials to describe our business and highlight the important question of how our company is accelerating the push to achieve the 1,000-mile electric vehicle battery using silicon anodes. Now, we are at a time in which our global automobile fleet are becoming electrified. By 2035, we're seeing the largest automotive markets, China, EU, and the US, becoming fully electrified. We have government initiatives and policies and corporate initiatives as well pushing for clean technology and zero-emission vehicles. However, the question comes to this. There are a lot of policies that push for zero-emission vehicles or electrical vehicles, but what stops consumers or what stops you from purchasing electric vehicles today? Well, there are several problems with electric vehicles, and I would like to highlight three key problems that are stopping you or stopping consumers from purchasing EVs today. When we take a look at key EV battery minerals today, the largest portion taking up the battery is graphite, taking up the biggest weight portion of the battery. Now, what happens as a result of placing too much graphite in the battery are three outcomes. First is with Inflating commodity prices, especially in the battery side, we're looking at inflating battery prices as well as EV prices that are discouraging consumers from purchasing electrical vehicles. And second, there are morbidly slow charging times. Now, we can see that a Tesla Model 3 in your home takes almost about 16 hours to charge. And also, lastly, there's anxiety problems with limited battery runtime. What if you have just 3% on the road while you're driving and the charger is many miles away? But what if we can tell you that there is a secret ingredient or mineral that can alleviate all three problems? And this is integrating silicon with graphite into the anode material. And let me highlight some benefits of using silicon in the battery. First is that we can enable ultra-fast charging if the silicon anode is manufactured right. And second, 9 to 10 times more capacity, or the capacity that determines the runtime of the battery, can be stored more compared to graphite in the same volume or weight. And lastly, the whole battery cost can be reduced as smaller amounts of silicon can give higher performance and longer ranges, faster charging than graphite itself. So you might be asking, then what is stopping the industry from using silicon instead of graphite? Well, here is the biggest problem of using silicon. When we use silicon in the battery, we charge the battery and the lithium ions go on into the silicon, and the silicon expands by almost 300% or 4 times the weight. And if we charge and discharge our batteries too much, the silicon becomes bigger and smaller and it eventually breaks down. So in the end, there's poor runtime, the battery life becomes very short, and there's slow charging, and it becomes unusable on the commercial level itself. So there is not a lot of batteries that are currently utilizing silicon itself in the battery right now. But this is where Neo Battery Materials comes in. Our Neo Battery Materials solution is nano coating materials onto the silicon itself. And if you see here on the diagram, the green dots represent the nano coating that's on the yellow silicon particle itself. So what we are able to do is that we control the volume expansion problem that happens within the silicon. And because we're able to solve the technical difficulty of volume expansion, we can place this into commercial level batteries, and runtimes are significantly extended compared to graphite anodes itself. And our nano coating enables ultra-fast charging. And the most important point about our technology is that we have low-cost manufacturing methods as well as low-cost inputs. Now, what this translates into is a scalable technology that can be used across all battery manufacturers and EV OEMs. And I'll touch on this on later slides. We would like to introduce you to NBMSiDE, our proprietary silicon anode product that we have launched in December of 2021. Currently, we have 3 products in the pipeline, and these 3 different variations represent different nano coating materials and thicknesses and different performance and specifications that we have received from large EV battery manufacturers and OEMs in the battery supply chain itself. The product itself was made by the former employees of the globally largest battery manufacturers, LG Chemical, or known as LG Energy Solutions today, and Samsung SDI. Along with our scientific advisory board and engineering team, they're making synergy together in order to make greater performances and optimizations for the product itself today. Taking a brief look at the silicon anode market, as I've just mentioned, the anode material of the battery is a big determinant of how long the battery runs and how fast the battery charges. And because silicon is known as the next material to enhance the lithium-ion battery and EV purchase itself, the market will grow up to about 15 billion USD by 2030, with 170,000 tons or 170 million kilograms of silicon anodes being produced by 2028 on an annual basis. Now, in the news, if you do your silicon anode research, there are a lot of competitors in the industry today. However, we would like to highlight that most of these companies are still developers of silicon anodes, and only 3 companies have been able to commercialize their silicon anodes. Well, you might think that, oh, there's only 3 competitors in the field. Isn't this a highly saturated or highly concentrated field? It's actually not, because silicon anodes is still a early stage technology that has not been massively used by battery manufacturers today. This means that there is no dominant competitor, which also translates into there not being a dominant technology out there in the industry today. So why might this be? Well, first of all, I've highlighted the problem with volume expansion and performance. And many of these competitors have been focusing so much on the performance that they have been foregoing the cost and the economics of the silicon anode. So competitors today in the industry use expensive manufacturing processes and expensive inputs for their silicon anodes. What does this translate into the manufacturing industry or industrial industry? Expensive costs means the lack of scalability, and lack of scalability translates into unattractive selling prices to battery manufacturers. So if you do a deep analysis of the industry today for silicon anode competitors, we're seeing that these competitors put in batch processes. So in engineering term, batch processes means that there is a fixed amount that can be only produced in one go of producing silicon anodes. But at Neo Battery Materials today, we're implementing a continuous process. So what this means is that we don't produce a fixed amount in a fixed amount of time, but we produce silicon anodes. We're aiming to produce silicon anodes 24/7, running the factory day and night. So this is where we are so much more different from the industry today. As we have already read the news release, or to those who are new, we implement a one-step nanocoating process. This is a simple and energy-efficient manufacturing process that is starkly different from the industry. Now, what the industry does is that they use highly sophisticated, complex, and expensive engineering environments. And these environments provide a good boost in performance, but this is a downward boost on their costs. But what we do is we don't sacrifice the performance, but we also don't sacrifice the costs. And this is one of the biggest differentiation strategies that Neo Battery Materials has been improving on. And along with low-cost inputs and coating materials, we're not only reducing the cost from the upstream, but we're also reducing the costs from the downstream. And this is what lithium-ion battery manufacturers want right now. And to highlight in a second point, we are the first to use and enable 10 times cheaper silicon input compared to the industry. And this is called metallurgical grade silicon. If you do your research on competitors in the industry right now, there are a lot of competitors using nanosilicon, silicon oxides, silicon carbides, or silicon nanowires, which do well in terms of performance, but the economics of these options are quite terrible in the sense that lithium-ion battery manufacturers are currently very sensitive to price increases in other components in the lithium-ion battery. We're seeing lithium prices spiking, nickel prices spiking, but they don't want to see silicon prices spiking in their anode material. So this is why lithium-ion battery manufacturers and other key EV battery supply chain players that we have talked to mentioned as our strength in our manufacturing process is that they realize that a Neo solution of implementing micro-sized metallurgical grade silicon is the way to go for the industry. Right now in the industry, if you see EV batteries that use silicon anodes, these are used in the most expensive premium electric vehicles. But what lithium-ion battery manufacturers wants to do in the 5-year and 10-year runway is to use silicon anodes in every type of EV model and make, regardless of what kind of consumer type they're looking towards. And this is where Neo Battery Materials steps in with this 10 times cheaper silicon. So not only can we increase our margins, but we can compete on price compared to our competitors. And this is a big value proposition that we are proud to share. And most recently, we signed an MOU with a producer of high purity silicon that recycles solar and semiconductor silicon byproduct waste. Now, what this gives is an opportunity to decrease our input cost by an additional 40% to fortify our position in terms of provide the most cost-effective silicon anode solutions in the industry today. Now, I would like to highlight some performance advantages of Neo Battery Materials. in the industry right now, I'll touch on the technical bits after the presentation, but the industry currently uses silicon oxides and carbides, as I've mentioned. But at Neo Battery Materials, we just solely use the silicon itself and we put a nano coating material on top of it. So in other words, we're just using the silicon itself. And because the sole silicon itself has so much battery capacity, our initial capacity is about 70 to 80% higher than our competitors. Now, what this means is that when Neo Battery Materials just needs 5% of our silicon anodes in a lithium-ion battery, competitors need 10% or 2 times as much. So what lithium-ion battery manufacturers can do is they can realize higher capacities or runtimes for the batteries while using less silicon. So saving more money, and there's more bang for the buck for the manufacturers there. And when we have discussed with EV supply chain players, they have emphasized that our performance that highly exceeds our competitors is the biggest proposition that we have alongside the cost-cutting metrics as well. And not only this, we also have an ultra flexibility characteristic that can be used in electronics and smart device applications. So we've been emphasizing a lot of electric vehicles, but also our silicon anodes can also be used in small electronic devices and smart device applications as well. And as devices are becoming more smaller in the market, there are more niche products that are coming out that requires flexible batteries. And flexible batteries are not easy to make, but our silicon nanocoating solution allows for ultra flexibility. So our products can not only be used in EV products, but also they can be used in electronic gadgets as well. And along with this, our nanocoating process enables ultra-fast charging. And as you can see on the diagram here on the right, there's more contact between the lithium and the silicon particles, which enables the ultra-fast charging. And this is what solves the slow charging issue of batteries today. Now, to highlight our business model and how we're going to incur cash flows is first, we are prioritizing our in-house manufacturing with our South Korean commercial plant. You may already know, but the initial capacity is about 240 tons per year. However, if we add mass production lines into the facility, we're looking at the full capacity of being about 2,000 to 5,000 tons, or about 5 million kilograms per year of silicon anode materials. And because we are in discussion with a lot of battery manufacturers, EV OEMs, and other chemical material companies in the battery supply chain, the next step would be to have joint ventures with these partners and also expand into North America and Europe and whatever strategic location that we see as fit for our silicon anodes. And another line of generating cash flows would be licensing our processes to these battery manufacturers and EV OEMs so they can vertically integrate our silicon anode manufacturing process into their factories directly. Now, we'll touch upon the commercialization pathways talk in the end of the webinar, but here is a brief development of our commercial plant in South Korea. Originally, we have planned for a pilot plant scale of 10 tons, but because our engineering team and scientific advisory board and management have all discussed that these results can be much more improved, we've increased this by 24-fold to 240 tons for the initial capacity. And this means that when we build the commercial plant by the first half of 2024, just loading 5% will allow us to supply to 160,000 electric vehicles. And with the lower end of the final annual capacity, the 2,000 tons would allow us to supply to about 1.3 million electric vehicles ongoing forward. Now, we will go on to the technical optimization of NBMSiDE, and we would like to give you more of a technical and more intricate overview of the current silicon options in the industry today and how Neo Battery Materials differs from these current options right now. So silicon has a theoretical specific capacity of up to 4,200 milliamp hours per gram. So milliamp hours per gram, you don't have to think of it complicated, but it's just a unit of how much capacity of lithium ions can be stored per weight in the silicon. So 4,200 milliamp hours per gram as an anode material, which is 10 times higher than the conventional graphite counterpart, which is only 370 milliamp hours per gram. So this has triggered strong scientific and theoretical interest in the industry. However, successful implementation of silicon as an anode material has been restricted by the following drawbacks. Now, if you see here on the chart, first, the large volume expansion induced by the charge and discharge process causes electrical contact loss or delamination in the second part, with continuous formation and growth of the solid electrolyte interface. Now, you see in the graph here, unstable SCI layer. So this is a layer that builds onto the silicon surface, and if it thickens too much, the silicon becomes unusable. Second, the poor electrical conductivity results in poor cycling performance and rate capability. So this is the charging capability. So to overcome these problems, substantial research has been conducted for effectively accommodating the large volume changes and enhancing the electrical conductivity of silicon during cycling, so during the charging cycles. So two solutions have been proposed as one of the alternative efforts for using silicon-based anode materials. So one would be to decrease the size of the silicon into the nanoscale, or to modify the silicon surface itself. So let us compare some silicon-based anode materials that have been currently developed or are under development. The categories can be largely divided into four groups: silicon carbides, silicon carbon composites, silicon oxides, and nano-sized silicon powder. So except for the nano-sized silicon powder, the current options utilize a supporting matrix, you can see here on the circle, to form silicon composites. These materials have different synthesis or manufacturing methods, energy capacities that determines how long the battery can run, initial coulombic efficiency, volume expansion suppression level, and other various characteristics. And as you can see from the table here, you can just simply think and observe by intuition that these synthesis or manufacturing methods, as I've just mentioned in the presentation, are not only difficult and complicated, but are also highly expensive just by nature itself. And you see these methods: chemical vapor deposition, mechanical pulverization, thermal plasma deposition, requires a lot of energy and time to process and manufacture these silicon anodes. So of course, these methods have their relative advantages, but in the industry today, battery cell manufacturers are finding difficulty implementing these solutions as they do not meet the required capacity, are expensive to meet profitability, and have particle sizes that are too small to handle. And you can see here that the silicon is about 5 nanometers in diameter, and smaller silicon particle means that there's more clumping problem of the silicon. And if the clumping problem cannot be solved, it cannot be effectively used in lithium-ion batteries today. But however, we Neo Battery Materials, as we have explained, are taking an innovative and unique approach that gets by these current industry challenges. So we are at the forefront of commercializing silicon materials that global cell manufacturers are attracted to and they want. By using micrometer scale metallurgical grade silicon materials through a simple continuous manufacturing synthesis process, we offer improved capacity, initial efficiency, performance, and most importantly, the costs as well. So building on our R&D Scale-Up Center update video, this is a brief description and diagram of how our NBMSiDE sample manufacturing and optimization process worked. So from April 2021 to May 2022, the nanocoating work, the post-task work, and material evaluation were carried out in and out of various sites and facilities because we didn't have these equipment all in one place. So as a result, there was a limit for quality assurance and control for each step-by-step condition. And there was another problem of time delays as a result of sending samples to different facilities. However, since May of 2022, we have been bringing in and procuring necessary pilot scale equipment into our R&D Scale-Up Center. And all of these step-by-step processes are being undertaken within the center right now. So as a before and after contrast, as opposed to the before when the samples were sent to different facilities, all these steps are taken within the Scale-Up Center today. Also, although time was taken to approve the conditions for operations of these pilot scale equipment, the engineering team is striving to improve the performance and economics of NBMSiDE materials by maximizing the advantage of quality control in our one-stop shop and by applying real-time improvements as an agile development approach. So this advantage has allowed to increase the sample manufacturing process, and we have been able to provide more amounts of optimized materials to our partners in the EV battery supply chain. The pilot scale equipment in the R&D Scale Center will also help our commercialization team with the detailed design of our mass production manufacturing lines, and then we expect a smooth transition to the commercial level through continuous validation of our products itself. Now, this is a technical graph in which we compare the before and after of our silicon anode materials. So comparing the silicon half cell initial capacity alongside with its initial efficiency, the initial efficiency of 85% and higher was verified to be almost equal to the capacity confirmed by a global major company in the EV battery supply chain that we have been working with. The improvements in our NBMSiDE materials have also shown characteristics in performance and costs that are superior to existing solutions in the industry. Please understand that we cannot show the public the detailed results due to competitive and confidentiality reasons. However, we would like to emphasize again that the large players that we are currently working with are highly attracted to the performance improvements that we have over the course of the 2 years. As mentioned, silicon anodes are only used in the most expensive premium electrical vehicles, but the goal of battery manufacturers are to implement silicon anodes in any kind of EVs today, not only with higher initial and overall capacity compared to competitors, but our partners are keen and eyeing on the cost advantage and economics of NBMSiDE silicon anodes. With real-time improvements in the center, we are making leaps of progress in our materials for the next stage of commercialization. So for those who have missed the last webinar, we would like to give you another aerial view and tour of the site and idea of what the facility will be looking like upon completion. So located in Gyeonggi Province of South Korea, the first commercial plant will be situated in the Osong Foreign Investment Zone in Pyeongtaek City. This is a greenfield project, and as mentioned, the facility has an approximate area of 106,700 square feet, or 2.5 acres, with an option to double land size. 99% of rent is reduced, and upon completion of the building structure, there are no payments to be made for lease. Various tax incentives will be applied, and business collaboration activities with the province is planned to occur. With technical improvements occurring at a fast pace, this progress is enabling us to further move forward with our commercial plant construction. We are proud to show you the final rendition of how the facility will look like upon completion here on the left image. In the beginning of December, we have submitted to the city of Pyeongtaek our construction permit. With the current due diligence period and expected approval by middle to end of January, the initial construction work is just around the corner. Once the OK sign is given, NEO Battery Materials will proceed first with the site clearance and basic civil engineering. And most importantly, a bid process to select the contractor will occur. With the current timeline, our commercial plant engineering team is in process with completing the detailed design and the necessary tasks to break ground as soon as possible. As the R&D Scale Center engineering team is concurrently delivering the optimized results to the large battery manufacturers, EV OEMs in the battery supply chain, the two teams are creating synergy, and we are glad to announce that we are on track of our construction plan and timeline. So we now move on to our talk on commercialization pathways. So for the past couple of years, NEO Battery Materials have been building significant relationships with large players in the EV battery supply chain. We first started with sending handmade silicon anode samples in the lab to now manufacturing level pilot scale equipment made samples. As we have mentioned, this has been largely enabled by our R&D Scale-Up Center. An effective tightening of our feedback loop, that is getting the samples and getting the feedback and bringing back optimized anodes, has allowed us to improve and enhance NBMSiDE to the performance and cost levels that we have been targeting, and these large players have been requesting for performance targets. The larger infrastructure, capacity, and equipment allows us to boost optimization and create better samples for NDA partners. We are currently matching the specifications and requirements that these large EV battery players are asking us. Their feedback with our results and development direction has been highly positive. As we have mentioned, as all other mineral components are experiencing price increases due to both demand and supply issues, battery and EV manufacturers are highly sensitive to costs right now. NBMSiDE's cost-effective manufacturing process and input is a high point of attraction to these manufacturers, and we are providing unmatched silicon anode solutions compared to the industry today. Plus, as NBMSiDE uses solely the silicon input itself without any modifications into an oxide or carbide supporting matrix, our testing parties comment that the significantly higher initial and overall capacity of our silicon anode materials can bring significant increases to the runtime of the battery and cost reductions for the whole lithium-ion battery itself. And because the initial capacity and performance tests by the parties that we have working with, large battery manufacturers and EV OEMs, they have given us the okay sign to scale up the test into a pouch cell as well. And we are continuing our validation and optimized sample sending currently with these players as well. So in the R&D Scale-Up Center, we have several battery charge and discharge cyclers that are being used to test our materials. And our optimized samples in terms of performance is getting better over time. Once certain levels and specifications are met, investors and the public can expect milestone deals to occur with these players. These include joint development, offtake, and collaboration agreements. So although a little different by the agreement, the important point to take away is that collaboration with large players will allow us to access more capacity, resources, and expertise to advance commercialization to the next stage. With over 40 NDAs within the battery industry currently, Neo Battery Materials is in discussion with a plethora of players to find an opportunity. And we are confident that both technical and construction advancements have attracted a lot of interest to our materials. And we would like to briefly give you an overview of how the sample testing process works. Now, we understand that there is a lot of patience that has to be dealt with sample testing, but we would like to give you what the intricate, not too much of the intricate details, but the high-level overview, what takes in the sample testing process between Neo Battery Materials and our counterparties. So when the counterparties receive our materials, there's not just one okay sign. They need to test their materials that has to be matched with their recipes in their lithium-ion batteries itself. And there are specific costs, performance, and other metrics that these manufacturers use that has to be good with our materials itself. So this is not just, oh, the material works, then we're going to use it. This is not that kind of process, but there has to be due diligence, back and forth feedback between the two parties. And this is what we have been doing for the past couple of years. We've been sending optimized samples back, and they've been testing our materials on bigger scale batteries so that there is robust validation for materials within these batteries itself. So just to give an overview, it's not just throw in the silicon and we're good, but the final anode material is comprised of mixing our silicon itself, the binder, which keeps the active material together, and the conductive additive, which promotes the electrical conductivity of the active material in different ratios. But they're just not 1:1:1. There are also different binders and conductive additive materials that will produce different performance results in the battery. So with these variables, testing conditions and charging rate protocols will affect performance as well. So even from this brief explanation, you can see that there are several variables that both parties need to consider and communicate before, during, and after testing. On top of this, charging and discharging the battery takes a great length of time. So as sample testing is not validated or performed on a one-dimensional criteria, as I've just mentioned, there is an excess amount of conversations and dialogues that must take place in order to optimize and improve the materials that are suitable for different battery manufacturers. And this is the reason why NEO is in deep and entrusted talks with these testing parties and we are going back and forth to match the specifications and needs. And there is high and great interest for our materials, especially with the costs and how our technology is scalable and implementable into their batteries, as well as the performance aspect, which we deliver one of the highest initial capacities in the industries today.
Okay, first of all, thank you very much, Danny. So I think we fully covered, on what we are doing and on what we are supposed to maximize our shareholders' value for the commercialization side. Overall. Okay. So probably most of the shareholders are interested in, yes, NBM needs to raise money. Yes, for sure. We have to raise money, going forward, to complete our construction of our anode plant. So as you might be aware, we raised $3 million from our strategic investor through NBM Korea. Because that is done 5 months ago. At the time, the financial market is also so volatile. It was very difficult to find the money raising source, but actually we were successful to raise money through NBM Korea. That also helped the save our shareholders' value of NBM. We have the same strategy, going forward, especially for NBM. My financial interest is exactly in line with all of our shareholders' interest. That's why we are looking for any type of non-dilutive funding to not cause any dilution of our NBM shareholders' value. That's why at this moment, we are currently talking to financial institution in South Korea for strategic, debt financing. So we just initiated this conversation, a month ago. I do believe there will be, meaningful, outcome, in the coming months, to secure strategic debt financing from Korean side through NBM Korea. And also, we are currently under process of change of business. There is, additional process to complete change of business process. We have to get approval from our shareholders meeting at AGM. So that could happen later February. So you will see that information circular, shortly. Based on that, on top of that, please do understand, I am not able to disclose the existing NDA counterparties. There is so strictly confidential. But anyway, at this year, probably there are some times we are able to disclose, some of the NDA counterparties through those kind of, potential, the milestones, such as joint ventures, joint development agreement, probably some strategic investment opportunity. I would expect that, in the first half of this year. Yes, some multiple discussions are on the way. Again, I cannot, disclose any kind of, specific names from our NDA counterparties at this moment. So our bottom line is to maximize our shareholders' value and to minimize, to de-risk, some more dilution risk for NBM shareholders' value. That is our bottom line. Again, I'm the largest shareholder of NBM. my financial interest is exactly in line with our shareholders' value. So that is the goal to maximize our shareholders' value. Probably some of our shareholders, are very sensitive on life cycle for the testing. Yes, it's very important because we just mentioned about initial capacity and also initial cooling efficiency. Because we had a lot of discussion and with a battery manufacturer in locally and overseas as well. When they initiate, the sample testing with us, they have certain, requirement to meet their, the numbers. That's initial capacity, absolutely, initial cooling efficiency, and also the life cycle as well. Because we did not, mention about our life cycle. Life cycle is very important, but for the initial sample testing with battery manufacturer, they have some of our shareholders talk about where is the test result for 1,000? Where is the test result for 2,000 life cycle? They don't talk about 1,000 life cycle because there is a typical, the agenda, typical protocol for, most of the battery manufacturer. They are looking into how well initial capacity and initial cooling efficiency and life cycle. They usually talk about, based on my experience and conversation with them, they're talking about when they initiate, when they evaluate the life cycle, they talk about 300 life cycle first, okay? So that's why I cannot tell, the more specific numbers at this time. So based on our R&D center, not kind of, from the lab scale, we are talking about, commercial level pilot scale at this moment for life cycle. We made a great, the improvement for the life cycle. So which battery, manufacturer, our NDA counterparties is happy with those kind of numbers in the life cycle. Again, it won't take a lot of time for our shareholders to see that, the result. And also on top of that, based on, I think based on that, the time we're gonna disclose the number of life cycle, including more improved initial capacity, initial cooling efficiency. That could be the time to achieve our milestone, the transaction. Probably, I hope, in the first half of this year. So that's why our researchers at R&D Center is working very hard at this moment, at this time, at this, our R&D Center lab, R&D Center to have a better, the life cycle performance, from our silicon anode materials. Yes, this is exactly, the currently on what we are doing at this moment. So probably for this, webinar, we could, I hope, I wish we could give you additional, the trust on what we are doing to move to the next stage. So again, to be clear, we have been great, improvement, for the past year to move to the next stage. Yes.
Yes. There's also investors and people who wonder about where the third-party validation results are, but we would like to give you a comment that third-party validation results are quite irrelevant and useless in our case. Third-party validation does not give validation for materials to be used on the commercial level, but validation by our battery manufacturer partners and EV OEM partners are actually what matters for validation. As we have mentioned, the sample testing happens with different recipes by manufacturer and by OEMs. And getting validation by a third party doesn't mean anything if they're not manufacturing the batteries. They can have good performance ratings for us, or bad performance ratings for us, but they don't mean anything for the battery manufacturers that we're working with. So we see that there's a better allocation of resources and time and energy and just financial capacities to be making more optimized samples for battery manufacturers instead of these third-party validation sites that don't give us real numbers or real advancements in commercialization. So you do not have to be so contingent and so reliant on these third-party validations. Because our NBMSiDE Scale-Up Center, we're making great progress in terms of performance and also improving the economics in terms of cost-wise, as we have mentioned. It's much better for us to improve better samples for these manufacturers than send samples off to third-party sites that don't give us any answers.
I'd like to emphasize, again, about our price competitiveness potential. Okay, here is the things. I can give you, the simple example. Through the multiple conversation with battery manufacturer and the battery expert. At this market, those who were, successfully to commercialized for silicon anode materials are selling their silicon anode materials. Again, based on my information, they are selling $80 to $100 US dollars per kilo to battery producers. Our price competitiveness, potential, we are using metallurgical silicon. When we had a discussion with that metallurgical silicon producers, if we will purchase, that metallurgical silicon based on 100 tons, in a large scale, they proposed to us they could provide $17 to $18 $17 to $18 US dollars per kilo. As you might be aware, we just had announced with the recycled silicon player. There is a chance, why I was so happy to find this recycled silicon player, because they hinted, they provided, they could provide that pure silicon with high grade down to $15 or $14 per kilo, possibly, which means that we could save additional 30 to 40% reduction for purchasing cost, which means will cause significant, price competitiveness compared to existing competitors. That's why this is and also our manufacturing process which is called continuous process. These two main characters, these two main processes are strengths. Most of the battery manufacturer are looking for at this moment, because they don't want to pay expensive money on silicon anode materials. And also the silicon anode market is growing. It's just growing. It has not been exploded yet. So that's why we strongly believe if we are successful to achieve on what we want to achieve this year, it could be a big milestone for us. It could significantly increase our shareholders' value this year. So I have never changed my vision. I have never changed my goal for NBM. Instead of that, because of the current, the improvement of our product, I'm more than motivated, so ever. So that's why I'm happy to have this webinar at this time with our valuable shareholders at this time. Thank you.
Yeah, just as a concluding remark and just a few key takeaways from our webinar today, we have fully developed our R&D Scale Center in South Korea, and this enables us to increase the feedback time with our battery manufacturers and EV OEMs that we are currently testing with. And because we're able to provide larger samples as well as quicker optimized samples, this is enabling us to improve the performances of our materials much faster than 2 years ago and then 1 year ago. EV battery manufacturers and these OEMs don't require the commercial level life silicon anode performance of 1,000, 2,000, 3,000 cycles. But these manufacturers are looking for potential in the performance and economics of our silicon anodes, which is around 300 cycles. And when the specifications and also the performances match the requirements of these manufacturers, you can expect, as we have seen here, the expected milestone activities of joint development agreements, offtake agreements, and or collaboration agreements. So what we're doing right now is, along with the South Korean non-dilutive financing, in which we have an MOU with Gyeonggi Province, is which we will explore more non-dilutive funding activities and opportunities with the province itself. We are confident to gain this funding from the government, as well as discussions with financial institutions in South Korea about strategic debt financing. This will produce synergies within our financial position and our shareholders' value as well. And just looking at the runway and the growth prospects of Neo Battery Materials, not only will funding come from these sources, but also when we have joint development agreements or collaboration agreements, we can also have joint venture activities with these large players in the battery supply chain. And they have the most robust and strongest financial position out there in the industry right now. And they will be able to supply their strategic investments into our company as well, so we can have funded expansions into territories that we still do not reach today.
Yes, I forgot to mention one thing. We are currently talking to multiple parties for strategic financing. Strategic equity financing for NBM. If they secure, their position, they will be a stakeholder, and they will be a long-term, investor for NBM. Not just the retail investors. Please remember that we are seeking for securing those kind of long-term investors to support us as a strategic investor. Yes, so again, our financial interest is exactly in line with your financial best interest. Please remember that. Yeah, that's my main goal. To maximize our shareholders' value.
All right. We have now come to the end of our webinar. So we hope that everybody had a great time and have taken away a lot of information in today's session. So we'll be holding webinars, and the subsequent session will be informed as a news release. If you hold any other questions, please do not hesitate to email us at info@neobatterymaterials.com. We will kindly return your emails, and we hope to see you soon. Thank you so much, everybody.
Thank you.
Thank you. Have a nice day. Good night.
Have a nice
Bye-bye.
day.